Well, hello there. This is Craig Hain. My students call me Dr. Dell. I'm the founder of Triad Math, Inc. And I've also written this book called Teaching Math in the 21st Century, a curriculum that works for all students. And this was done back in 2011. And you can get a free copy of this if you go to the triadmathinc.com website and download it in a PDF format. And this video today is on what we call our STEM Math Bootcamp. And what we're really going to talk about is STEM and the 21st century modern math tools needed for STEM. Now, as I'm sure you know, STEM is an acronym for Science, Technology, Engineering, and Mathematics. And in this bootcamp, you're going to learn about a modern 21st century tool that literally revolutionizes how STEM professionals solve calculus and differential equation problems in linear algebra. Now, this tool we're going to talk to you about today that we're going to use in this boot camp was introduced to the world in 2009, and it's free via the internet, and it's called Wolfram Alpha. Now, Wolfram Alpha does to classical calculus and differential equation courses what the HP35 scientific calculator did to slide rules and log and trig tables back in 1972, only now we're in the 21st century. If by chance you've taken a 21st century calculus and differential equations course, like the ones we do in tiers 5 and 6 in Triad Math's program, then this boot camp is simply going to be a review, and there will not be any new material or information. And you can go to the triadmathinc.com website to look at the syllabi for those courses and see how we do it. On the other hand, if you've had a classical calculus and differential equations course, mostly which are taught today in most of our schools, then this is going to be a revolutionary program for you. Now, to convince yourself of that, simply take the 12 questions quiz at stemmathacademy.com and you'll see why this is so. Also, if you've never studied calculus or differential equations at all, then this boot camp is all you're really going to need for engineering and science. And on top of that, it'll be a great tool if by chance you for some reason have to study a classical course in calculus or differential equations. Maybe that'll be required where you're going. Now, this boot camp is not going to teach you these classical tools that are taught today in calculus and differential equations because they're obsolete, just like slide rules are obsolete since the advent of the scientific calculator. Now, we do assume that you have had at least a classical pre-calculus course, which most students will have had in just about any high school they've gone to. Now, if you want to determine whether or not you have really had enough material in pre-calculus, we recommend that you go to Dr. George Simmons' great book called Pre-Calculus Mathematics in a Nutshell, Geometry, Algebra, and Trigonometry, and review the subject. This book you can get at Amazon for about $15, and of course it is the book that we utilize in Tier 4 of Triad Math's program. We do a lot more than just in this book, but this would be what would be done classically in a book. Now, I'm going to tell you a little bit about this book, but first I want to tell you a little more about Dr. George Simmons, who in my opinion was one of the great math teachers of the 20th century. Back in 1962, he wrote a book called Topology and Modern Analysis, which is used in advanced theoretical math that's taught in science and engineering if you're going to study quantum theory or theoretical physics. And I taught several courses out of this book in the late 1960s and the early 1970s at Indiana State University and Rose-Hulman Institute of Technology in Indiana. And it was just a wonderful book. Now, in 1972, Dr. Simmons then came out, notice it's a decade later, with a book on differential equations, and he updated it in 1991, and it's this book right here. And if you're going to study differential equations from a historical viewpoint, a classical way, this is the book I recommend. Dr. Simmons' book on differential equations is absolutely fabulous, and I highly recommend it to you if you want to study differential equations the way it was taught classically. Then in 1985, Dr. Simmons came out with a book called Calculus and Analytical Geometry. Now, once again, if you want to study calculus and analytical geometry the classical way, I highly recommend this book. This is a very detailed book. It's got a lot of historical information in it, and it's a wonderful way to learn calculus in the classical way. Then finally, in 1987, I think Dr. Simmons decided that students just weren't prepared with pre-calculus enough to come into these calculus and differential equations courses, and he wrote his great book called Pre-Calculus Mathematics in a Nutshell, Geometry and Algebra and Trigonometry. And this is the book we use in Tier 4, and it is only 119 pages long, and it covers the pre-calculus math that you need for this workshop and that you should have had. Now, it's only a 119 page long book. It only costs about $15 on Amazon, and that's what makes it so amazing. And in fact, the reason I wanted to tell you about Dr. Simmons is to know that he really knew what he was talking about. He wrote the greatest book on differential equations I've ever read. He wrote the best calculus book that I know about, and of course he wrote the advanced topology and modern analysis book. So he really knows what he's talking about, and this is a really great book, and it's a good way for you to review to see if you really are ready then for this workshop. Okay, now, the most basic concept that you've got to fully understand, and it permeates all of STEM subjects, is the concept of a function. Calculus and differential equations, in fact, are simply a bunch of concepts and tools that are used to analyze and understand functions, which are the basic building block in STEM models. Now, here's some of the things that you should already know from pre-calculus. A function consists of three things, of course. It has a domain, which is usually a subset of the real numbers. It has a range, which is a subset of the real or the complex numbers, and then it has a rule or a formula for assigning a unique number that's in the range to every number that was in the domain. And that's what a function is, and you've learned all about that in Dr. Simmons' book or your pre-calculus training. Y equals f parentheses x, so it's read y equals f of x, is a typical notation where x represents any number in the domain of the function. Y then, or f of x, is the unique number assigned to x that's in the range. And there are many other notations you can use. Z equals g of t, for example, would be the same thing, where t is the independent variable representing a domain element, and z is the dependent variable representing a range element. And you can use lots of different notations, but you get the idea, and this is something you should know from pre-calculus. Now, here are some of the common functions that you ought to be familiar with and have some understanding of from your pre-calculus training. Polynomial functions and rational functions, which are the quotients of polynomial functions. Exponential functions and their inverses, which are logarithmic functions. These are the notations for them. The trigonometric functions. You should understand those, sines and cosines and inverse sines and cosines. And composite functions, where you combine these together. You also should have some understanding of implicitly defined functions, where you have an equation that implicitly defines one or more functions. And these are just some examples you probably have learned in pre-calculus. Now, the first thing that you have to do in STEM is to graph a function. And that's the set of all the points x comma f of x in the plane, where x is in the domain, and of course f of x was the range element. Because the graph is what you have to use to understand the behavior of the function. It's much easier to understand it from the graph than it is from some formula. And of course, we know that graphs are very difficult to create manually, and they're best to be created by a computer. Now, as you might guess, Wolfram Alpha graphs all functions, whether they're explicitly or implicitly defined, in great detail, and it's a wonderful way to do that. However, in STEM, you've got to know a lot more about a function than just its graph. For example, you've got to know where it crosses the x-axis or its roots. You've got to know the stationary points, where the slope of the graph is 0. These are sometimes called critical points. You've got to know its relative maximum and its relative minimum points. You've got to know the regions where it's increasing and decreasing. You've got to know its points of inflection, where its concavity changes from up to down. And you've got to know its asymptotes, both the vertical asymptotes and the ones as x goes to plus or minus infinity. Now, as a matter of fact, all of this is covered in a calculus course in Calculus 1 in what's called differential calculus. But the old manual techniques for doing this are very, very complicated and difficult and time-consuming, and Wolfram Alpha does all of this automatically for you. That's what you're going to learn in this boot camp. Then you also want to know the area under the graph of a function from A to B, or you want to know the arc length of the graph from AF of A to BF of B. Or you want to know the volume and the surface area of a solid of revolution if you would rotate that graph about the x-axis. You also want to be able to answer all these questions for implicitly defined functions. Now, This is what's covered in integral calculus, and as a matter of fact, it's very difficult, and it's what actually has probably, in my opinion, flunked more kids out of a STEM career than anything else. It's called Calculus 2, Techniques of Integration. And of course, you want to know things like, how can you approximate a function with a polynomial? Again, that's a more advanced thing from differential calculus. Now, all of these questions are occasionally, sometimes answered in classical calculus with the manual tools, but always with difficulty. Well, as a matter of fact, with Wolfram Alpha, you can do all of these very quickly and easily, and even things you can't do classically. Many things you can't do classically. Finally, in STEM, sometimes you have what is called a differential equation, and you can think of this as an equation where the variable is actually now a function. And of course, the challenge then is to find this unknown function. Well, this is what the subject of differential equations does. And it's very messy, it's very time-consuming, it's very hard to understand, a bunch of ad hoc techniques. In fact, differential equations are essentially an extension of calculus. As a matter of fact, integral calculus is really the first time you try to solve a differential equation so that you can apply what is called the fundamental theorem of calculus to solve definite integral problems. And this is what gives students a tremendous amount of trouble classically. A lot of kids have flunked out of school and given up on STEM just because of this right here. Well, that's all over now, and that's what this boot camp is going to teach you with this modern 21st century tool. Now here's what you have to realize. Historically, in the 17th and 18th and 19th centuries, many wonderful tools and techniques were devised to solve these calculus and differential equation problems. In fact, calculus goes back into the late 1600s. It was invented by Leibniz and Newton in the late 1600s. And then Euler in the 1700s, the 18th century, really developed essentially all the tools that are taught in calculus today and in differential equations. A little bit was added in the 1800s or the 19th century. But essentially, this was all done back in these horse and buggy days. These were fabulous inventions our ancestors did. I mean, I'm amazed by them, and it made modern science possible. It was wonderful stuff. But they were manual techniques. They didn't have calculators. They didn't have computers. They didn't have modern technology. And these manual techniques are very difficult to master and to understand. Even today, they're tough. And they're also very limited in scope. There's a lot of things you simply cannot do with these manual techniques. We have to rig up the problems in calculus and differential equations so students can solve them. You just can't take an arbitrary STEM problem and expect them to solve them with these manual techniques. They just don't work. I think of these as horse and buggy days. Now, those are wonderful days. I mean, you know, compared to before horse and buggy days, it was great. But they're now obsolete. Now, this may be sad, and a lot of math educators don't like to face up to it. They still want to teach it, but it's true. A modern tool like Wolfram Alpha just simply makes these classical tools obsolete. You're not going to use them anymore. No STEM professional is going to use these tools today. No one's going to pay you to use them. Why is that? Well, everything you want to know about functions now can be determined very easily and very quickly with a modern tool like Wolfram Alpha. If you don't believe me, just take the 12-question quiz that we have at the STEM Math Academy I mentioned above. This quiz is very difficult, bordering, I would say, impossible with classical tools. But it's very easy with a modern tool like Wolfram Alpha, and that's what you're going to be faced with in science and engineering today. And that's what you're going to learn all about in this boot camp. Any student who understands the modern tool and how to use it and is proficient with it is going to have a tremendous advantage over any student that only knows the classical manual tools that are still taught in many of our calculus and differential equation courses today. And as a matter of fact, we think that this STEM boot camp is going to free up a student to pursue a STEM career that would otherwise be very, very difficult. And I might add, if you get caught up in having to take a classical calculus and differential equation course, I think this tool will help you. It won't substitute for it, but it might make it a little bit easier. But in any event, you'll be ready for science and engineering once you learn how to use this tool, and that's what this boot camp will do for you. So now go back and visit the STEM Math Academy website, or the Triad Math Inc. website, and study this even further. And if you're talking to any expert in STEM today, a teacher perhaps, that's questionable about that, have them go to the STEM Math Academy and take the 12-question quiz to see what this is all about. Print out these notes and share them with people. Take a PDF copy and print it. And hopefully, once you understand this, you'll be able to take advantage of this boot camp. Or go back and download your free PDF copy of the Teaching Math book and read it. I predicted all this 5 years ago, back in 2011, and it's come true, and this is where we are today. So hopefully I'll see you in the STEM Math Bootcamp.